Welcome, everybody. This is a pretty full room. That's cool. So there's lots of interest in machine learning, machine intelligence. So in this presentation, we'll do an overview of what's available within the Google Cloud Platform. So we'll be speaking about APIs available, about even open source and solutions to scale your machine language needs. So I am Guillaume Laforge. I'm a developer advocate for Google Cloud Platform, and
I'm Martin Gorner. And some of you have seen me already on Monday and Tuesday in the TensorFlow sessions. I will be showing a little bit of TensorFlow here as well.
So for those who were in the keynote, I'm going to show you again this little slide. In the 80s, there was what we call the AI winter. So there had been lots of research with neural networks, etc. in the 80s. I mean, the algorithms were there. But what really changed, the real breakthrough, and why machine learning is so, in the front of the news everywhere, or every company is adding some sort of machine learning everywhere. That's really because there's a huge quantity of data available that we have to do something with. What can we do with that? What can we learn from those data sets? Also, what's interesting is that we have lots of labeled data sets so that neural networks can learn from these and say, okay, this data means this is something, this data, that's something else. So there are labels, like this is good, this is bad, spam, not spam, etc. This is a car, this is an animal, etc. But in addition to that, so obviously, you need also to store that data. It's not necessarily data you can fit inside one single computer and its hard drives. You might have tons of terabytes of data, and perhaps your hard drives are not big enough. So that's why the cloud is helpful, even just for that aspect of data set size. But also, the big change is all this cloud computing stuff. Because we are now able to have tons of compute power available to train massive neural networks and also to train bigger models. And that's this little circle, this chain, with obviously ongoing research in order to refine the algorithms, optimizations, etc.
And I'd like to add that those big models was the key. That's why we are talking about deep learning, because we realized that by stacking layers in a neural network, suddenly that neural network could do a lot more things. Previously, the idea existed, but we didn't have the CPU to compute those.
Yeah, definitely. So that's why AI and machine learning is there everywhere. So an example, so you've got your pictures of vacations, and I mean, before pictures, so let's say if you used whichever photo service available, you had to manually kind of label your data if you wanted to find later on, okay, which vacation that was, or let's say pictures of your friends or your family or something. But what's nice is that now computers are really able to figure out what's inside those pixels for real, and it's able to figure out that, okay, there's a woman there, there's a pool, there's the coast, the beach, water, etc. And instead of, I remember myself, I mean, going through my own pictures and having to flick through tons of pictures till I really managed to find something. Okay, no, not that. Oh, that should be around that date, and then going through 100 of pictures before finding what I'm looking for. Now, I'm really able to do a search and find the right pictures. That's actually what I did for a demo I'll be showing later on, where I'll show you the Vision API. I actually searched for past pictures I knew I had taken, and thanks to the search, it managed to find the right picture. But I'll come back to that.
And you're doing this with Google Photos?
Yeah, with yeah.
This is available today in Google Photos. For everyone who uses Google Photos, you can search by content.
And the fact that, I mean, all the users of Google Photos uploading billions. I don't know how many pictures we have from all the, all the users.
200 million users.
Yeah,
that
must be quite a number of pictures. And especially our devices are sending those pictures automatically in Google Photos. So that's a lot of pictures. And yeah, machine learning is everywhere. So Translate is using machine learning and neural networks for that. Inbox, the mobile version of Inbox, when you're using the smart replies. And I'm taking that example on purpose because there's an interesting example and demo that Martin is going to show you later on, where it figures out what is the likely response you're going to give. And it auto completes the beginning of it auto writes the beginning of your email because it knows more or less what you're going to talk about. So yeah, machine learning is everywhere, not just at Google anyway. So that's interesting. So I'll redo and spend a tiny bit more time on my demo from the keynote yesterday, where I implemented my poor man assistant. And this time I have a bit more time to show you a bit more the details of the calls that I made. So where is my Vim? It's here. So basically, it's really just like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 10 lines of code, I was able to record some. So perhaps I should launch it first so that you see to refresh your memory. So what am I going to ask? Is there a conference about machine learning? So I'm recording the audio. I'm going to store that in Google Cloud Storage. Then I'm going to call the Cloud Speech API to do the recognition of the speech. And then I'm using, so let's see concretely step by step. So where is it? Hop, there. So I used a little command line tool. I'm going to zoom here, called SOX that I installed on my machine to record the audio. So I recorded that with a FLAC file. Then I'm uploading here the content to Google Cloud Storage. Then I prepare a request that I'm going to send to, well, I shouldn't highlight because it's even less readable. So this is the request I'm going to send to the speech API, pointing at the place where I stored my audio file. Then the result of the call is here. Is there a conference about machine learning? So it properly recognized, despite the echo and everything, it recognized the text very accurately. So this is the text recognized. Then once I'm there, I'm going to use the natural language API to actually analyze the content of that sentence. And so this is the result of that call. So how many sentences? Well, there's just one. And what's interesting here is that it analyzed the structure of the text. The big breakthrough here, but I'll come back to that, is how you can really understand the structure of text. So it's not just mere characters and words, but it's really, okay, this is a noun, this is the subject of the sentence, this is an adjective, this is a preposition, etc. So it's really figuring out the different parts of the speech. And then there's also, I'm not really using it for that demo, but there's also a sentiment analysis that you see, where's my cursor, that you see here. So is it a positive sentence or not? Then I have I extracted the words, and I'm interested in the add position part, which is about what, and the keywords I'm interested in here are machine learning. And then I used Google search actually to find inside the Devox CFP the talks which are related to machine learning with a simple query. So this, and I'll come back to showing you more concretely some of these things with some online demos afterwards. Okay, so I'm coming back here. So showing up, yeah. So we've got, it's like a spectrum of machine learning solutions. So if you're a developer, you want to use on-the-shelf APIs, REST APIs, or using the Java SDKs that we have, you are able to call ready-made APIs, so you don't have to be a data scientist, so it's concrete use case, but somewhat limited, I mean, in the sense that it focuses just on speech, vision, etc. But you can do already interesting things with that. On the other end of the spectrum, you've got TensorFlow, which is an open source framework which allows you to really define exactly how you want to create your neural networks. And then in the middle, you can also leverage the infrastructure of the Google Cloud Platform to train at scale on huge data sets the neural networks to do predictions, classifications, etc. So we'll focus first on TensorFlow. And I'll let the experts speak. I'm not an expert in that.
Let me show you just a little bit of TensorFlow. There is a longer session right after this, if you're interested. So you will be slightly disappointed. You might not understand all the codes on the slide. It's not the point of those 5-10 minutes here. It's just to give you an overview, see a bit of code, and try to do something fun with a neural network. Neural networks usually look like this. They come in layers, and the neurons, they always do the same thing. They do a weighted sum of all the inputs and produce some output. And all the trick of training neural networks is figuring out those weights in the weighted sum, and you do that through training. Here, I want to play with a specific neural network, which is called a recurrent neural network. The specificity is that it has a vector as an input, which might be anything, but the state, I mean the outputs of that intermediate layer, we pump it back into the input at each time step. So this can actually be represented as a simple cell. It has a vector as an input, produces a vector as an output, and also produces a state which you pump back in at each time step. This is a recurrent neural network. And that's what we are going to do with it. We are going to build a language model. We are going to put on the inputs characters from a piece of text. How do we encode those characters? Well, the traditional encoding is called one-hot. Basically, you have an alphabet size of, let's say, 100 possible characters. So a vector representing a character is a vector of 100 elements, all zeros just to one somewhere in the middle, saying this is the index of the character. And to train a recurrent network, you unroll it a certain number of times. So you replicate one cell multiple times. Then you put in characters, it will produce characters on the outputs. And you will say, no, that's not the characters I want. I'm going to train you, and I'm telling you these are the characters I want. It's the same sequence shifted by one character. So actually, what I'm training the neural network here to do is to predict the next character based on an input sequence. So let's try to write this in TensorFlow. First of all, you have a high-level call in TensorFlow to create one of those cells. It's called a groove cell here because there are several types of those cells. I've shown you one. The groove cell is slightly more complicated. But still, input, output, and a state that is passed around. You heard about deep learning. So yes, we need many layers. That's simple. A second call to stack this cell high. Again, doesn't change the structure. Still, one input, one output, and one state that is now slightly bigger that is passed around. And a third call in TensorFlow to unroll this sequence a certain number of times. How many times? Well, that's in the x, which is the input. It simply depends on the size of the vector. All right, we are ready to train this. So to train, as I said, we put characters on the input. It produces outputs. We say the output we want is the same sequence shifted by one. This in turn produces a difference between what we want and what it says, and we use this difference as an error function to minimize through training. This is the full code of this neural network. Okay, so again, I'm not asking you to understand everything, it's just a little snippet, but I want you to take away that the full code for training this neural network is on one slide. And you recognize there, in the middle of the left side, my model, the cell stacked high, and unrolled. The rest is basically pumping in inputs and outputs, and you have one very important thing. Look at the top of the screen, Adam Optimizer. So this is what TensorFlow gives you as really added value. You take an optimizer, you compute this loss, this error between what the network says and what you want it to say, and you ask the optimizer to optimize this. It will optimize this across many iterations, pumping in new data, new desired outputs, and so on. And this is mathematically quite a complex operation. Usually it's called backpropagation and so on. In TensorFlow, it's one line, and that is really the game changer. The rest, that's the training loop. You pump in characters, and run the actual training step that the optimizer gave you. All right, so I've done this on the entire works of William Shakespeare. Let's see what this gives us. So what I'm going to do, now that this network has been trained, is take just one of those cells, put in garbage. It gives me a character probability in the output. I roll the dice, take one character from this probability, put it back inside. And suddenly, I'm generating text. So let's see what our neural network can tell us. How can it generate text?
Oops, don't move it.
No, I'm here. So first of all, in TensorFlow, you have a save command. During training, you can save all the weights and biases of the system. So let's see what this does with a network that has been trained on a few passes on a few plays. All right, and now I need a run.
It's not C. I think you typed in the wrong place now.
Did I? Oh, yes, I did.
And you typed
Sorry about that.
Somewhere else. What was
C3.
that? I saw. Yeah, I do.
Okay. So now I need a run. Now I run something else, which obviously is not what I wanted. Run. Here we go. Ooh, so it's already starting to look like a play. Well, it's not really English, but still, you see something that looks like a character name, and then characters with spaces. All right, it hasn't learned much yet. Let's try a little bit more advanced, like this.
But is it harder to understand than the real Shakespeare plays, or?
Well, it's still not completely English, so
okay.
I think there is progress to be made here.
Good.
All right, how about this one? Ooh, look, this is starting to be English. And look at this.
Characters.
You have characters.
Yeah.
The short words are okay. There is feet, there is me, there is two. The character names, look, they are recognizable. Fintense, Porteman, not quite yet perfect, but this is starting to look like a play.
But it's Old English anyway.
It's Old English, so you can't understand it, of course.
That's why.
But now let's try to push this to the very end. Now I trained this on the entire Shakespeare corpus, I think 10 times. Let's hit run.
Scroll.
Whoa, look at this. I have actor 3, scene 1, a pledge sound. I have scenic indication, enter Gloucester. I have a full monologue. I have actually credible character names. What are they?
Warwick.
Oh, sorry.
Yeah.
I have Warwick.
King
I have
Henry
a gentlewoman.
VIII.
Look, it picked up the fact that when it's a name, it's full caps, and when it's a character like a gentlewoman, a soldier, and so on, the capitalization is different. It learned, this is actually generated character by character. It has learned how to spell English. Not yet correctly, because actually I forgot.
And that's at that moment that we ask the audience to actually play the play that is generated. Who wants to?
Who wants to play hallucinated Shakespeare? Come on, we need a volunteer.
Too much Belgian beer. perhaps.
No, we need a volunteer. This is a good idea.
Okay.
Who wants to play? Yes, please come on. Please come on. Come on. You can play Donadios or Juliet. Would you want to play Juliet? Look, well, sir, what news? And look, this is real English. The soul of all their strength, indeed the benefit, that work themselves to save the reason of a father, as if it would be so about to be a sound. It's almost like real Shakespeare,
Makes
isn't
sense.
it? All right. And actually, what I find nice is that you actually get those scenic indications like enter a messenger, re-enter exit, re-enter third rights. All that is generated character by character. It had to first pick up the syntax of English, how to spell words, then the syntax of a play, and so on. All right. So that's the little funny network I wanted to build with you. All right. Let me stop this. And now, if you have a network like this, actually, I also tried it on the full Python code of TensorFlow itself. So at the beginning, it didn't understand much. But then, look, it has the keywords right already. It's starting to open some function names a little bit further. Well, the keywords are right. It's actually hallucinating function names.
Properly
like
indented.
test, giden, self, b, share, macros.
That's how the code of TensorFlow was written, actually.
Of course.
In case you wondered.
The parenthesis nesting is not quite there yet, but look, 12 epochs, so 12 times the entire code base, the parenthesis nesting is correct at triple depth. It can recite the Apache license entirely, and it figured out how to do comments. It's giving me TensorFlow tips. Look, create the string operation to apply gradient terms that also batch. That's very important. And the original of any operation as a code when we should always infer to the session case. Always infer to the session case. Remember that.
And that's also how the documentation of the website of TensorFlow was written.
All right. And the gentleman who actually built this neural network for the first time is called Andrei Karpathy. He's got a nice blog about this. He tried it on an algebra book written in LaTeX, and actually the network produces almost syntactically correct LaTeX. He had to fix it a little bit, but this is what he gets. He gets an algebra book, hallucinated. And I love the proofs. So look at the first proof. Proof omitted. That's clever. That's clever. All right. So now, if you have these networks, it takes a lot of CPU to train them. So we built this service called CloudML, which is a hosted service where you can throw your TensorFlow and build it on a distributed infrastructure in the cloud. So how does it work? Let me show you. First of all, what is the algorithm for training in a distributed neural network? Well, it's like this. You put your model on multiple servers. You pump in training data. Now, during training, this training data generates, that's the training algorithm, little deltas, little modifications to your internal weights and biases. And you hope that those modifications will change the weights and biases so that your network becomes better and better. So when you do it in a distributed way, all of those servers are sending the updates to the weights and biases, then getting the new weights and biases and restarting. Now, if you ask me why this works mathematically, I mean, this server is sending biases, adding them to the deltas, adding them to the existing biases, but maybe those biases have been updated already by another server. How can this work? Mathematically, it doesn't work. It's not correct. It's actually not correct. But this being not correct is actually just a little bit of additional noise, and it happens that these things, to converge, they kind of like noise. So even if it's mathematically totally incorrect, and my math teacher would slap me if I did this, well, in the real world, this approach works quite well.
But perhaps show the math proof that you generated to your math teacher. He might be happy.
Omitted.
Omitted.
All right. A few pieces of code to show you how to package this for CloudML. So this time I'm showing you a higher level API in TensorFlow that has layers. So in my model function, I have layers. Each layer is a different kind of layer in my neural network. This is a complicated one, a convolutional one, whatever. My model function, I use it to build an estimator by passing it in the estimator. And the estimator in this higher-level TensorFlow API, that is the object that has the fit function that does the training and the predict function that does the prediction. Give it something and it tells you what it is. Now, I can call the fit function to the training myself on my computer, but I can also use it to build an experiment. And an experiment is basically an estimator plus data feed functions. So, of course, if your data is small, like here, you just load the data in memory, and it's a constant, so no need to anything fancy. But usually, the data is huge, and there is a possibility in TensorFlow to insert in your computation graph nodes that, during training, actually pull data. So that's what you define in those train input function, eval input function, and whatever. Basically, the model is your layers, neural network layers. You put this into an estimator, which gives you the ability to call fit, which means train and predict and so on. And if you add data feeding functions to the mix, you get an experiment, and an experiment, you can run it on Google Cloud Platform, CloudML. Learner.run. Let's run it. So to run it, it's here.
Yeah, the second tab.
Yep.
Oops.
Here we go.
A command line.
It's a simple command line. You have to package your code in a folder, okay, not too complicated. My code is in task.py, and there is this config file, which basically tells the system how many replicas I want for training. I'm using standard one, which is basically a fixed set, which says 3 model replicas and 1 parameter server.
So instead of doing that over days, hours or days or weeks on your local machine, you can spread that across tons of machines.
Exactly. You can speed it up by simply parallelizing this. Mm-hmm. And it's a very good approach also to run this on your local GPU. That gives you a good boost, like 10x. Mm. But after that, a computer with 2, 3, 4, 8 GPUs, that's not so handy. So that's where you switch to CloudML, where you can put this on multiple replicas. Even if they don't have GPUs right now, you can have as many as you want.
And with 8 GPUs, you might be playing some nice games on your machine, right?
Oh, yeah. All right, so I launched this. It's queued. Let me just see. So I have to find what it is. A browser?
No, it's in the right, on the right.
Okay, I have a browser somewhere.
Stop the presentation mode, and it's there.
Oh, thank you. So, this one?
Yes.
All right. So here in Cloud Platform, I've got machine learning somewhere right here. And in my machine learning, I have now created a job, which is the job number 27. If I go into it, I can view the logs. And if I view the logs, it tells me that there is something running here. Running. It's actually launching my nodes, doing the training, and so on. And the result from this training, I will see in cloud storage, because it's actually storing in cloud storage as soon as I find it.
Yes.
Cloud storage here in jobs, train 27. It's storing data to visualize the progress. That's using TensorBoard. That's a tool for visualizing progress. And very soon I will have here checkpoints that it's saved those are checkpoints with all the weights and the biases of the trained system at one given time. So from those checkpoints, I can create a model that then I use for serving. CloudML can also do that. CloudML can do the training part, and CloudML can be used for serving if you need to put your trained model in use in an application. All right, so now let's see what people did with this. Because I do agree that, just launching it, seeing it train is maybe not such an impressive demo. But what I find impressive is that what people were able to do with this. We have a company in Japan. They are a used car reseller. And their problem was that they get used cars. They take pictures of them, and they want to make sense of those pictures. It would be nice if this could be done automatically. So they need image recognition for car models, car parts like a tire, steering wheel, and so on. Well, this is usually a hard problem because you need millions of images to recognize such kinds of high-level features. But there is a simple approach. We at Google, we have built this model called Inception for recognizing images. It was trained on millions of images for recognition tasks of whatever. But actually, you can chop off just the last layers and use the full beginning as a fixed encoding function for your images and train a small neural network just to recognize on those encoded features if this is a Toyota 94 or if this is a steering wheel and so on. To do that, first of all, you use significantly less neurons than here, so you need significantly less compute time and significantly less images. It's actually doable for a used car reseller. Let's see a demo of what they did. So, escape again, and I'm here. Let me throw some images at this. One level up, and. Which one is it? Oknet, I see it.
Oknet, yeah, got it.
And it's this one.
Take them all. Coach them all.
Yep. Oh, sorry. I can just do this. Open. So it's uploading these images, and very soon it will start recognizing. This is not an API. This is a neural network they built themselves by repurposing the open source Inception network already fully trained. They took all the weights from GitHub, just chopped off the last layers, retrained those. And look, we have a gauge, the rear side of the car, we have a steering wheel, the front side of the car, the right side, front side, blah, blah, blah. Very soon it's going to tell me which, we have a dashboard, and it's telling me that it's maybe a 2012 Toyota Cruiser, maybe a 994 or a 205 Toyota Land Cruiser. The first guess is, I think, the most accurate. Very practical application done by a real company, not specialized in machine learning. And of course, they needed CloudML to do this because they don't have, it's not a ML research lab. They don't have those computers with 20 GPUs that they could have used for this.
To play car games.
To play car games, yes, exactly.
But yeah, that's interesting because it's really, so you see the front, the rear, right side, it really recognized the angle and the detail and everything. That's quite
and actually on the slides
impressive.
We have a link to both the open source version of the Inception network, and there is a short code lab that teaches you how to retrain it on another data set.
Very nice. Yeah, so let's not forget
full TensorFlow session, so with all the details, all the gory details this time, right after this if you're still awake.
In this room.
If you're asleep, doesn't matter. It means you will stay here. That's the goal.
So we saw the TensorFlow parts. We saw cloud machine learning. Now let's come back to the higher stack with ready-made models, which you can use as an API directly with a Java SDK, with a REST call. So the machine learning APIs that we have, let's have a look at the natural language API. This API has got several features. Let's start with, let's say, sentiment analysis. So you can say, okay, this sentence or this body of text is very positive, or no, it's very negative, and with which magnitude. Is it very negative or a bit negative? We also have entity recognition. So it's able to figure out, okay, this word there in the text is the name of the new president of the United States. So it might be a negative sentiment, I don't know. Then the syntax analysis, that's what I explained earlier. You really have the understanding of the various words of the text. So if I just come back, also what's nice, and I'm going to show you that in a second. Where's my cursor? It's there. So for example, if you go, can increase a little bit, it might be better. So if you go to, can even start from scratch. So if you go on the Google Cloud Platform website, cloudgoogle.com, products, and then you see all the tons of available products, blah, blah, blah. Where's the, yeah, it's there. So the machine learning ones, if you go to each of them, you'll see, I'm clicking again on this one, so Cloud Natural Language API. On each of these APIs, you also have the a box where you can actually play with those APIs directly. So yeah, I can try this one. It's a complex phrase. So it recognizes some entities like Google, Mountain View, etc. So Google, it's an organization. So it's even qualified information. So you really know what kind of things it is, like a person, a location, an event, etc. And there are also links to Wikipedia pages. And for things like, so persons, etc. And so is it something positive or negative? Yes, sounds like the sentence is pretty positive. Magnitude, yeah, not quite average. So I'm going to use another sentence, like the one like, is there a conference about machine learning? And I'm going to show you the exact structure of this sentence that I used in my demo earlier. So conference is an event, machine learning, not sure what it is, it's other, something else. Sentiment, it's positive. And this one. So if you look at the structure, you can see like the subject of this sentence is conference, and there's an add position with the preposition about that points at the actual topic I was interested in. So I'm able to figure out, okay, if I want to create an API, an app, an assistant for conferences, I could say, okay, is there a university, is there a talk, is there a quickie, etc. So it can figure out what I'm really searching for, and then it can tell the search engine or whatever is next to figure out, okay, this is inside this add position. Machine learning is the actual content I'm really interested in. So that's what you can do by really understanding the structure of your sentences. So it's not just a list of words, it's really a tree representing the structure of your text. So this is pretty nice, not just characters and words. So this was the demo. Let me come back in presentation mode. The Cloud Translation API, well, this one you certainly know. It's actually an old API at Google. It's been there for a while, but we keep on improving it, versions after versions with even more text, etc. So you can pick between, I think, 80 plus languages, and to translate from one language into another language. So a quick demo, but this one is not very impressive because you certainly know it very well. Oh yeah, je suis sur scène in French, but I'm going to use something. Shakespeare, non, mon professeur de maths est nul. My English, let's see what's going to be my math teacher is 0. Oh, 0, nice. I mean, you know, it could have said is bad or something. No, 0 on math, that makes sense, right? So this is the translation API. So yeah, I think there are over 80 languages which are supported by this API. Back to the slide here. The Google Speech API, that's what I showed in the demo. So you can, it supports several different audio formats. It allows you to get the transcript of the text that's being said. What's interesting as well is that, so no, actually I said 80 languages, but was that for, yeah, that was for the speech API. For the translate API, perhaps it's even more than that. I don't remember the figure. I had this 80 in mind, but that was for the speech API. But the translation API really recognizes tons and tons of languages. Also, what's interesting with this API, so although I used it in a, let's say, synchronous mode, in a non-streaming mode, it also supports a streaming mode. So you don't have to, let's say, okay, I'm going to speak for an hour, blah, 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 like today. And at the end, I do the speech recognition. Okay, well, you could do that, but what's more interesting is if you can do that speech recognition while the person is speaking. And so the demo online, though, works non-streaming, but it's also possible to use the streaming approach to have the recognition happening as the speaker actually speaks.
And that's what you see when you talk to your Android phone.
Yeah, exactly.
It's the exact same technology used behind the scenes.
So when you type, not type, but you speak to your phone, for a text message or something like that, you actually see it doing that live in a streaming fashion. Yeah. So yeah, over 80 languages supported. The streaming. Oh yeah, it's also able to filter inappropriate content. So in the text that is returned, it's going to replace the curse words and things like that with. I don't remember what it uses, but it can get rid of those curse words. And also, it's been trained not on just nice sounding voices without any noise around, etc., but it's been trained on real samples of data in people who are in the street, who are in noisy places, etc. So it's pretty good at recognizing voices, even in noisy environments. I'm not going to show that one. Okay. This demo, because I showed it earlier. So the Cloud Vision API, so just like in the example with the pictures, recognizing the pictures of my vacations, what it supports in terms of features, so there's face recognition, with things like giving the sentiment or if the person is happy or sad, etc. Label detection to recognize what's inside pictures. OCR, so if there's some text in the pictures, it's going to extract the text from those pictures. It can recognize also logos. If you have naked pictures and things like that, it's also able to figure out if it's something that you should be able to display. Like imagine on a website, people upload pictures and you don't want, and pictures are viewable by anybody, and you don't want guys or ladies, why not? It's usually guys who do that, upload naked pictures or something nasty like this. So there's this ability there, and landmarks detection. So if you take a picture of something pretty well known, like a monument or something, it's able to recognize that. I'm going to show this again in action. Vision, where is my cursor? It's there. So here I'm on the Cloud Vision API page, and I can upload some pictures. So I'm not going to take the car this time, but I'm going to use ML pictures. I think that's this one. So this year I didn't take that picture, but I didn't have to go through all my pictures thanks to Google Photo. I knew that. I come to Antwerp every year for DevOps, and last year I had taken a nice picture of the cathedral. And it actually recognized the cathedral, so Cathedral of Our Lady. And if you look at, let's say, the map, you're going to see, it looks like it's Antwerp. And some labels, so this is a building, this is a cathedral at night, a place of worship, okay? Somehow, this one is a little bit weird, but if you look here, some sculpture there somehow looked like 3 and 3. well, that was a bit surprising to me, but well, sometimes it can figure out some text in some places. Oh, it also gives some useful information like common colors that you see in the picture. Safe search, okay, is it something safe to see? Yes, and this is the structure, but I'm going to show the structure in another example. Another example, so this one, that's the train station, and again, it manages to recognize it pretty easily. More interesting, not that the train station is not interesting, but let's say, okay, you have faces. So this is a picture I took with James Strachan. We co-invented the Groovy programming language. But look, and what was funny is that I wanted two faces, but then it even recognized the faces in the Twitter wall. Okay, wow. So face one, that's me. Face two, that's James. And yeah, okay, joy, very likely. Yeah, we are smiling. Headwear, both we were wearing glasses, and this is the other face as well. And there's also some text here and there, although it was written very small, but there's okay, rate song, managing cloud-native applications, etc. And let's say I think I have one more. Yes, spoofing, this one. Oh no, or this one. Again on the OCR part. So someone gave me a card with the local taxi driver because there were some issues with the tram the other day. And okay, writing, hand, and then yeah, it probably recognized the text, and it gives you the bounding boxes showing where the text actually is. And the very last one I wanted to show you, there's also, so I said that it can figure out if there's naked or unsafe kind of content, but things like spoofing, when people add their own comments to pictures, it's able to figure out that, okay, someone somehow altered the picture with adding some particular text. So this is very likely. It's stronger in terms of adult. Did you see that? Oh,
fries are not good for children.
Okay, might be it.
But you mean there is a meme detector in there?
Yeah, probably.
That's very good. Right?
Neurons really learn lots of interesting things. Oh yeah, the Wix media. You wanted to
yes,
cover that one?
We also wanted to show you what a company, Wix. You know them. They have this fantastic website builder. And again, no developers specialized in machine learning. This is a pure web company, but they took the Vision API and did something really useful with it. Mm-hmm. They have a problem. They have gazillions of images. When people build websites, they both upload images, they need stock images, and so on. So they have these gazillions of images, and for the users, it's a bit daunting to find the right image in the stock images, in the paid images. It's part of their business model. They also sell images. So what they did is that they indexed all of them. And that's the Cloud Vision API, very simply. They passed all of their millions of images into the Cloud Vision API to index the landmarks, to index the people in it, and so on. And they have a searchable database of images for their customers. You're building a website about San Francisco, you search San Francisco, Bay Bridge, whatever. Boom, you've got a picture of that. You can use it. You've got the rights alongside, if it's free, if it's a paid picture. They also run these through face detection. And it's face detection. It's not face recognition. It tells you there is a face here. It doesn't tell you this is Guillaume Laforge. Or it doesn't even tell you this is gentleman number 27. It's just a box telling you there is a face here. But one very useful feature you can do with that, it gives you the box. So you can provide to your users an auto-cropping function around the face. If you want to put faces on your website, you only have a big picture, send the big picture, auto-crop on the faces, pick one, job done. A very useful feature that, again, they implemented very simply using just the Vision API. And, that's all I wanted to tell you about them. It's a problem that was regarded as intractable. Actually, if you want the full story, sometime in the 60s, I think, when computers were invented, when the first image processing was done, a computer science professor thought, well, we can do image processing. Now we can do image recognition. That's an easy problem. He called his colleagues and said, well, let's take our, each of you come with your 2 best PhDs. We'll do a summary tree, 2 months, we'll solve this. They didn't. We are 50 years later, but now it's been solved. Recognizing the Bay Bridge in an image, recognizing a cat in an image, recognizing a person in an image in a completely automated way on large sizes, or category sizes, like all the monuments on planet Earth, all the landmarks. That is a solved problem. It's easy today. There is an API for it, and there are algorithms for it, if that is something you want to do at home. So I find this progress really remarkable, and even more remarkable how useful it is in real life.
Mm-mm. And compare it, so, I mean, myself, I use, stock photo websites for my presentations.
Yeah.
And often you've got labels for pictures, manually entered and so on. But with that, you can really say, okay, I want this and that in the picture, and it's going to return the right picture for my need.
Those labels, up to now, people had to enter them manually, so they are...
Yeah.
The quality is the quality of the manual work that was done. Mm-hmm. That is expensive.
That's brilliant. All right. So in terms of ready-made APIs, we spoke about the natural language analysis, the Translate API, the Vision API, the speech recognition API, and as you can see, what's interesting as well is also when you combine them, like in my little assistant, poor man assistant demo, it's fairly easy to just combine a few of them and provide some interesting products. And sometimes with existing models, like with TensorFlow, you can then reuse a model and do something else to tailored to your needs. So this is the whole spectrum, TensorFlow, train that in the cloud, and ready-made APIs, depending on whether you're a researcher or not necessarily with a PhD, I know, or if you're an API developer and want to benefit from ready-made APIs. Here are interesting links. Also, before you all go away, we also have T-shirts, by the way, if you want some Google Cloud T-shirts, which are here. To give away, and so here are the links to the various APIs that we have, the TensorFlow open source project, and also this interesting one on the TensorFlow for Poets.
That is the Inception retraining
that
code
you
lab.
Explained. Right. So join the discussion on Twitter, Slack, GitHub. You're welcome, and thanks a lot for your attention.